Hi everyone, let's work on example 5 for solving applications involving right triangles. Number 5 has a 28-foot long, what are we looking at? A 28-foot long ladder leaning against the side of the building. If the angle between the ladder and the building is 20 degrees, how far does the top of the ladder move down the building if the distance between the building and the ladder increases by 2 feet? Okay, so that was kind of a lot. So let's say here's the side of our building. Here's the ground. We have a 28-foot long ladder, and we know that the angle between the ladder and the building is 20 degrees. So 28 feet long and 20 degrees. And we want to know if the top of the ladder moves down the building. Oh, we want to know how far the top of the ladder moves down the building if the bottom of the ladder kicks out 2 additional feet. So basically this ladder is going to change position. It's not going to be our 20-degree angle anymore. This is going to be a little bit lower, and it's going to stick out a little bit further. So if this was x, this will be x plus 2 feet. And we want to know if this was our height, what is our new height? How different is our new height? Okay, so that's what we're working on. We do have a 90 in both triangles. Okay, so, oh, and we do have one more thing. This is still the 28-foot ladder. If we're going to answer this question, I think we need to know something about the original height and the original distance x from the corner to the bottom of the ladder, which means we've got to do a couple of things when we're solving. So let's say we first want to go for x. If I want a trig function to relate this angle, 20 degrees, to x, and the known hypotenuse 28, I'm going to say opposite and hypotenuse, that's sine. So sine of 28 is it 28? 20 degrees. Sine of 20 degrees is equal to opposite x over hypotenuse 28, which means x is 28 times the sine of 20 degrees. Okay, and we can check on our calculator. 28 sine 20 gives me about 9.58. So x is approximately 9.58 feet. Okay, so now we have the base. I'd also like to find the height. You can do this using trig functions again, or you could also use a Pythagorean theorem. That's entirely up to you. So I'm going to run through a Pythagorean theorem just to mix it up a little bit, but it would be fine as well to use a cosine. Okay, so I'm going to say if we're looking for side h, we should be taking the hypotenuse squared, and we should be subtracting the other leg, x, squared, and then we should be square rooting. So again, I encourage you to try and jump straight to the final version of that quadratic or Pythagorean theorem. Okay, so I want a square root of 28 squared minus 9 point, and here, you know what? Oh, I shouldn't have cleared it. Okay, it would have been nice for me to not clear my answer, and then I could have saved myself a little rounding error, but we'll go for it. Okay, so it looks like h is about 26.31 feet. Okay, so we have a ladder that initially, for triangle number 1, extends 26.31 feet up the wall and sticks out 9.58 feet from the bottom of the building. So now we need to move over to our second triangle and say, all right, well then that means that this is now 11.58 feet out from the wall, and we're looking for this second, I'm going to call this H2. So this one could be our H1 even. Okay, so now we're looking for H2, and once again, actually I take it back. You don't have great choices here because we don't have a known angle in either corner. The only one we know is 90. So here I think I would definitely use a Pythagorean theorem. So for triangle 2, I'm going to say h2 is the square root of 28 squared minus 11.58 squared. And I can just snag that last little bit that I typed in. 1. If you want to add a 1 in there without having to retype the whole thing, if you do second and then delete right next to your arrow keys, that gives you an insert. You can just sneak in an extra 1. And I'm getting 25.49. H2 is about 25.49 feet. Okay, so we've got lots of info. The original triangle had a height of 26.31 feet. The new triangle has a height of 25.49 feet. We wanted to know how far down the wall the top of the ladder slipped. So we just need to subtract the two. And it looks like it dropped by not quite a foot, 0.82. Okay, so dropped by about 0.82 feet. All right, thanks for watching.